Okay, everybody, it's January 5th, and I've got a speed controller working on my wheelchair robot wheels. I'm using a couple of Mosfets, and I'll try to publish information on these. And then I'm using a BJT to switch it on and off, and I'm using a pulse width signal from my Fpga. I've got a power supply providing 24 volts for the motor. And normally this thing books it, but using the pulse width switching mode here on the Mosfets, I can get it to run kind of slow. You can hear the ringing noise coming from the motor because of the frequency of my pulse width, and that I am going to have to mess with because it does warm up this heat sink a little bit. And you can see my pulse width signal right there, throttling the motor speed. So I'm just reusing some code for pulse width on here, so I can't adjust the speed, but you can see essentially by adjusting the width of the pulse, you adjust the duty cycle on the motor, and that gives you variable speeds. And by adjusting the frequency at which the pulse width updates, you can affect whether or not you can hear this ringing noise that's audible here. That's just because it's in the human hearing frequency. And like I said, this does get hot because of the switching speed I'm using, and by adjusting that, I'm hoping I can affect how hot that gets. Plus, I'm probably going to have to vary some resistor values and tune this thing, but I just wanted to get the video out there and show that it's working. And hopefully I'll get this thing into a full H-bridge configuration instead of just a pulse width. And I'll try to keep you posted. I abandoned the BJT, the larger one that was in the previous video, because that thing has so much internal resistance that this kind of current draw, it would just explode. So it would have been it's a lot easier just to go with Mosfets for this kind of thing and then use BJTs to switch the Mosfets. But I'm probably going to redesign this using a hex buffer instead of the BJTs, and then use pull-up resistors. Anyway, more to come.